For this video, we will be discussing about arcs and chords. For our objectives, we have 1. Identify and illustrate theorems on arcs and chords. Number 2. Determine the geometric relationship and the measure of arcs and chords of a circle using the theorems. And 3. Solve problems using theorems on arcs and chords. Now, let us first recall the terms related to circle. Identify what part of a circle is being illustrated and described below. Given the circle, for the number 1, the blue dot labeled with letter O is known as the blank of the circle. Number 2, the green line from the point O to A is called blank. Number 3, the orange line from the point B to C is called blank. Number 4, the arc that is formed by pink dots from C to D to E is called blank. And for the number 5, the angle AOE is called blank angle. So if you try to answer, for the first item, this blue dot labeled with letter O is known as the center of the circle. Number 2, this green line from point O to A is called the radius. Then, the orange line from point B to C is called the chord. For the number 4, the arc that is formed by pink dots C, D, and E is called major arc. And for the number 5, the angle AOE is specifically known as central angle. Since you already mastered the terms related to circle, you are now ready to answer Activity 4, Pair Me, on page 13 of your learning package. Arcs and chords. Let us start with these definitions. Congruent circles are circles with congruent radii or radiuses. Let us have this example. AB is the radius of circle A, and OP is the radius of circle O. So if AB here is congruent to this OP, then the circle A is congruent to circle O. Next, congruent arcs are arcs of the same circle or congruent circles with equal measures. For example, given circle O, if the measure of arc BA is 45 and the measure of arc CD is 45, then arc BA is congruent to arc CD. Theorems on arcs and chords. Radius-chord theorem. If a radius of a circle is perpendicular to a chord, then the radius bisect the chord. Given this illustration, if radius OP is perpendicular to chord MN, then this radius OP bisect or divided this MN into two equal parts. That means that this MQ is, for example, is equal to 16 centimeter, then this QN is also equal to 16 centimeter. It's because if we speak of bisect, it divides a line, an arc, or anything into two equal parts. In this case, it divides the line or the chord MN into two equal parts. That is why here MQ is equal to QN. Next, converse of radius-chord theorem. If a radius of a circle bisect a chord that is not a diameter, then that radius is perpendicular to the chord. Given this illustration, for example, if radius OP bisect chord MN at point Q, then this OP is perpendicular to MN. For example, if radius OP bisect the chord MN, that means that this MQ is equal to QN based from the previous theorem. So, this also implies that this OP is perpendicular to MN. That is what we meant by converse of radius-chord. So using your knowledge about the first few theorems, let us try this example 1. What is the length of the radius if OQ is 10 cm and MN is 32 cm? Here's the illustration. So, by Pythagorean theorem, we can solve this problem. C squared is equal to A squared plus B squared. Our C here is the radius OM. Our A is the MQ. And since MN is 32, as said in the problem, and OP, this OP is perpendicular to MN, and radius OP bisect MN, then our MQ here is 16 by just dividing 32 by 2. Our B here is the OQ, which is equal to 10 centimeter. Here, just substitute the value that will become OM squared is equal to 16 squared, which is the value of MQ, plus 10 squared, which is the value of OQ squared. Then square both sides. Then it will become OM is equal to square root of 16 squared plus 10 squared. Hence, we will arrive at approximately 18.87. Therefore, the radius OM measures 18.87 centimeter. Next theorem, chords of congruent circles theorem. In congruent circles, if two chords are the same distance from the center, then they are congruent. For instance, Given this illustration, given two congruent circles X and B, if XZ measures 4 centimeters and BD also measures 4 centimeters, this means that XC and BD are equal. And then, this also implies that this chord WY and AC are congruent. Another theorem is in the same circle or in congruent circles, the congruent arcs have congruent chords. For instance, if AB is congruent to CD, then chord AB is also congruent to chord CD. Number 2. Congruent chords have congruent arcs. In this illustration, if this chord AB is congruent to chord CD, then this arc AB is also congruent to arc CD. In this illustration, if the measure of the arcs are equal, then the measures of these chords are equal too, and vice versa. So in this illustration, if arc AB and arc CD has 68 or has congruent measures which is 68, then their chords are also congruent, which is 25 centimeter both chord AB and chord CD. That is what we meant by this theorem. So let us have this example too. A chord of a circle is 20 centimeter long and is 6 centimeter long from the center. How long is a chord that is 4 centimeter from the center? Hint? Can you find the radius? So in this illustration, the OB is the radius. So what was our given? We are given AB, which measures 20 centimeter. OP, which measures 6 centimeter. OW, 4 centimeter. And our BP here, 10 centimeter. Just 1/2 of this AB. Okay, for our first step, we are going to solve for OD. We all know that OB here is our radius, and OD also is radius. So meaning these two are just equal. So using Pythagorean theorem, OB squared is equal to OP squared plus BP squared. So we are given OP, which is 6. So here OP squared is equal to 6 squared plus BP squared. Our BP here is 10, that's why it's 10 squared. Square both sides, then we'll get 2 square root of 34. Our OB is equal to 2 square root of 34. Since our OB is just equal to OD, then our OD here is also 2 square root of 34. Our next step is to solve for dW. OD squared is equal to OW squared plus dW squared. So our OD here is 2 square root of 34. Erase it by 2, then it will become 136. So our OW is 4, and OW squared is equal to 4 squared plus dW. Transpose this 4 squared here, it will become 136 minus 16, then it will become 120. Square both sides, then dw is equal to square root of 120. So our goal is to find CD. In finding CD, it is equal to 2 times dw. We just need to multiply this square root of 120 by 2. Then we will arrive at approximately 21.91. Therefore, the chord that is 4 cm from the center is 21.91 centimeter long. This chord CD that is 4 cm from the center is 21.91 centimeter long. Let's now move on to the example number 3. Find the value of x. So given this illustration, if AB, this chord AB, is congruent to chord CD, then this arc AB is congruent to arc CD. That is according to the theorem that if the chords are congruent, then its arcs are congruent. So here, if arc AB measures 80 degrees, then arc CD also measures 80 degrees. So here, our CD, or the value of x, will be 80 degrees. Therefore, our x here is 80 degrees. For example number 4, given a circle M congruent to circle J and the arc AE is congruent to arc BD, find AE. So this is the illustration. So since as said in the problem that arc AE is congruent to BD, it implies that AE, chord AE, is congruent to chord BD. Since that is the case, we're just going to equate this equation and this one. That's 3x plus 8 is equal to 6x minus 1. And it will become 6x minus 3x, which is 3x, and 8 plus 1, which is 9. Divide both sides by 3, then it will become 3. The value of x is 3. Since we are looking for the AE, we will use this equation, or this one, 3x plus 8. Since we find the value of x, which is 3, we just need to substitute this x to 3x plus 8. Then it will become 3 times 3 is 9 plus 8 is 17. Therefore, this chord AE measures 17 centimeter. For the last theorem, if a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc with the same endpoints. So given this illustration, in circle O, ME here is the diameter and XY is a chord. So if ME is perpendicular to XY, then it means that AX is congruent to AY. Also, XE, or the arc XE, is congruent to arc YE. For example, here ME is perpendicular to XY. If the value of AX is 12 cm, then the value of AY is also 12 cm. If the value of arc XE is 45 degree, And then the value of YE is also 45 degrees. For our example, so in this circle O, ME is perpendicular to XY. We are going to find the value of XY, if AX is 10. So for our solution, using the previous theorem, we all know that AX is congruent to AY. And in finding the value of XY, it's just AX plus AY. Since we all know that the value of AX is 10, therefore the value of Y is also 10. So 10 plus 10 is 20. So the value of XY here will be 20 centimeter. So since you already know the different theorems on arcs and chords, you are now ready to answer Activity 5. It's raining arcs and chords on page 16 of your learning package. And Activity 6, always, sometimes, never, on page 17.